All right, good morning. I was actually going to teach a new lesson today, but I decided not to. So I'm going to give one gallant effort on these transformations. And what I need you to do is, if you're confused about something, try to let your pride down and let me know what you're confused about. Okay, because I'm going to try to clear it up once and for all today. So let me talk about a couple things first. First of all, all right, this right here is the equation of just a regular function. And you notice this is f of x. So f of x. So this regular general function, it could look like some weird thing. As long as it passes the vertical line test, it's just a function that it's not one of our regular equations like the quadratic. So we know this is the quadratic because of the square. We know this is absolute value because of the absolute value bars. So what I need you guys to know is when it's a regular function, you're going to have to get the points off the graph. If they don't give you a graph, you can't do a transformation. You need to be able to look at this one and say, oh, that's a quadratic. It looks like this. Oh, that's absolute value. It looks like a V. So that's the one thing that I absolutely need to have you know is what the parents look like. So does it look like a snake? Does it look like a V? The cube root is a sideways snake. So I think there's 5 of them you have to know, and I can't remember them for you. I mean, you've got to look at that parent sheet and know what the graphs look like. If you don't know what the graphs look like, you can't do the problem. You have to know what the graph looks like. So the other thing I need you to know is about H and K. Now, H and K do not change the graph. So H moves things left and right, and K moves things up and down. So for example, if I had a square, it's like taking my hand and just moving it around. So notice that it's not changing shape. So if I want to move it over here, I can move it up there if I want. If I want to move it over here, I can just take my hand and move it. Okay, that is it's not changing shape, it's just moving it around. And this moving it around is called a translation. And when you're doing a translation, you add or subtract. So in other words, adding and subtracting doesn't change the graph. It just moves it left and right, up and down. That's all it does. On the other hand, this A and B, which by the way, in your lesson, they're afraid to give you B. Maybe they don't think you can do it. I don't know. But today I'm going to be giving you B. But in all of your problems, if you look at all your problems, they're not giving you B. Okay, this morphs the graph. And morphing means it changes what it looks like, which is called a transformation. And all you have to do is remember the movie Transformers, because they took a car and it transformed into a robot. So it completely changed. So it no longer looked like a car at all. It looked like a robot that was walking around. So when you want to morph or do a transformation, you have to multiply. So I'm straight out telling you that when you have H and K, you're going to be adding and subtracting. When you have A and B, it's going to be a transformation where you have to multiply and change the graph. Okay, so you need to know what the graph looks like. You need to know what A, B, H, and K do. And you also need to know when you have H and K, you add and subtract. When you have A and B, you multiply. Now, the other thing that I was trying to get across to you is that when I taught this, when something is inside, it's horizontal. So this H is left and right, and this B is a horizontal stretch or compression. When it's outside, it's vertical. So it's either moving the graph up and down by adding or subtracting, or it's a vertical stretch or compression. All right, so let me get into that. So it seems like some of my students are confused about the stretches and compressions. So I'm going to go over this. So I'm going to write down a bunch of numbers. So 6, 4, 3, 2, -5, -3. -9, 1/2, 2/3, 5/8, 24 over 39. No, 37. 25 over 26. And then over here we have 3/2. 9/4. 11/3, 15/4, 17/9. Now, first of all,
your camera's like off, like I can't see you. It's just like your icon.
Really?
Oh, there you go. Never mind. It loaded.
Okay. So the negatives have to do with reflections. So, okay, so that's the other thing I need you to know before we do this. You need to know the order. So the order is left, right, which has to do with H, adding or subtracting. This is stretches and compressions. And in your book, they call them shrinks. That has to do with A and B. 3, the reflections, have to do with negatives. And 4, up and down, has to do with K. So you deal with H, then you deal with A or B, and then you deal with K last. So these negatives, I'm going to erase them because they have nothing to do with stretches or compressions, and that's what I'm talking about right now. So I'm just going to erase all these negatives. Wherever there's a negative, I'm erasing it because that has to do with reflections. So basically, I'm going to give you some examples here. You have to be able to recognize when something is inside the square, inside the cube, inside the absolute value, inside the cube, or outside. So the first thing is with your eyes. So hopefully all of you can see that these are 4 totally different problems. They kind of look alike, but they're completely different. So the next thing I need you to be able to see is that this 2 and 1, they're outside the square. This 2 and 1/2 are inside the square. And even if I put parentheses around this, it's still outside the square. So outside means vertical. Inside means horizontal. So that's the first thing you have to determine. Is it vertical or horizontal? Now, here's the deal. If you have any of these numbers, including these, because this is really 1 1/2, this is really 2 1/4, this is really 3 2/3, and so on. These numbers right here are different because those numbers are between 0 and 1, or 0 and -1. So if the number is between 0 and 1, or 0 and -1, it's a proper fraction. And if it's a proper fraction, it means it's a compression. So this would be a vertical compression by 1/2. And these are improper fractions, so they're bigger than 1. These are bigger than 1. Anything bigger than 1 is going to be a stretch. So anytime you have a proper fraction, it's a compression. So stretch, stretch, compression. So now we go here. Now, these are the problems that they didn't give you, but I want us to go over them. When you have, these are A, by the way. Inside would be the B's. Now, what you have to remember about the B's only is you take the reciprocal. So this isn't really a 2. It's 1/2. So once again, since 1/2 is a proper fraction, that would be a horizontal compression by 1/2. And when you take this reciprocal, it would be a horizontal stretch by 2. So don't confuse things, okay? All you have to do is when you see B, you have to take the reciprocal. Don't negate it or do anything. You just take the reciprocal. This would be a horizontal compression by 1/2. This would be a horizontal stretch by 2. All right, does anybody want to ask me a question about this before I erase it? Now, this doesn't matter, you know, if I make this a cubic, the same thing goes. If I erase these, and I make these guys absolute value, same thing goes. So it's always this way. When it's outside, it's vertical. When it's inside, it's horizontal. All right. So please ask me a question. If you have a question about something you're confused about, please ask me now. Because in my opinion, if you don't have any questions, it means you should be able to do this perfectly. If you cannot do this perfectly, it means you have questions, so please ask me.
So if it's greater than 1, it's a stretch, and if it's a fraction, it's a compression.
If it's greater than 1, it is a stretch. So like this fraction right here, that's not a compression. And the reason why it's an improper fraction, this really means 2 1/3, right? So you're right. If it's greater than 1, it is a stretch. All right, anything else? All right, well, I'm going to see what's going on here finally. So today what we're going to do, I was going to teach a new lesson, but I'm not. What we're going to do is we're going to be going back and forth, WebEx, Teams, WebEx, Teams, WebEx, Teams, because I want to see if you understand this or not. So I'm going to give you a problem. I'm going to give you so much time to do it. You're going to do it in your team. All right, so let's do this problem first. Actually, let me do a problem first, so I can model what I want. All right, there's 4 things that I want. The first thing is to look at the problem and draw what it looks like. So absolute value looks like a V, so draw it. That's the first thing. The second thing is you're going to state the transformation in the correct order. So this would be left 3, and that is outside the absolute value, so that would be a vertical stretch by 2. Okay, now, if you can't remember the points, remember you can take the parent and come up with the points on your own. But remember that absolute value is like the quadratic. The points are left 1, up 1, 0, 0, right 1, up 1. And like I said, if you can't remember that, put in a -1, absolute value is 1. Put in a 0, absolute value is 0. Put in a 1, absolute value of 1 is 1. So now, left 3 means the x. So subtract 3 would be -4, subtract 3 would be -3, and subtract 3 would be a -2, and the y values stay the same. Okay, vertical means y. So, and vertical stretch means we're going to transform it or morph it, so the x stays the same, and we're going to multiply the y by 2. Multiply the y by 2. Multiply the y by 2. So those are 3 things so far. You're going to draw the picture. You're going to state the transformation. You're going to show the transformational points, and then you're going to graph it. So left 4 down 2. Left 3, 0. And left 2, let's see, left 4 up 2, sorry. Left 4 up 2, left 3, 0, left 2, up 2. And remember, this is a V because it's absolute value. So I always kind of like to look at it and say, okay, well, it was shifted left and it looks like it was vertically stretched. So I have a high level of confidence we did it right. Okay, now, when I go into the teams, I want you talking through this. If you don't, I'm just going to ignore you today. So I'm going to give up on you today. I'm not going to give up on you for good, but I'm not going to mess with you today. So I want there to be a discussion about what you're doing. If you're not discussing it, I'm just going to ignore you today. All right, so let me tell you again what you're doing. You're drawing the picture of what the graph looks like. You're stating the transformation in the correct order. You're showing the transformational points, and you're graphing it. Okay, so let me give you a problem. I'm going to give you so much time to do it. I will give you a little bit more time on the first problem, but we're going to be moving things along here. And if you don't know what the parents look like, you have to look at that sheet. I mean, you've got to study, you guys. I was talking to the AP Calculus teacher this morning. I'm like, they can't remember anything. It's like, I feel like you just do the lessons, but you're not studying. You're not studying the parents. You're not memorizing the order for the transformations. If you plan on taking any math in the future, you've got to learn how to study. There's only so much I can do. You got to either have these papers in front of you, or you got to memorize them. You've got to study. Okay. So there's your problem. You're going to draw a picture of what it looks like. You're going to state the transformation in the correct order. You're going to show the transformational points of whatever this graph is, the parent points, and you're going to graph it. All right. It's 11:11, and I'm going to give you a little bit more time this time. I'm not going to give you as much time next time. So you're going to come back here at 11:20. So next time you only get 5 minutes. So this time, 11:20, you're going to come back and we're going to take a look at it. Okay, I'll see you in the teams. I'll see you back here at 11:20. All right, hopefully you made it back. Now, like I said, this next time we do this, I'm gonna speed it up a little bit. So you got to really be on your game about what things look like. So first of all, I asked you to state what this looks like. This is a parabola. And then I want you to state the transformation in the correct order. This is right 1, which does not change shape. And this is up 2, which does not change shape. So you need to know what points come with the parabola. And if you don't know, you can write down the parent and figure them out. So put in a -1, quantity squared is 1. Put in a 0, 0 squared is 0. Put in a 1, 1 squared is 1. So right 1 means add 1 to the x. Add 1 to the x. Add 1 to the x. The y's don't change. Up 2 means add 2 to the y. The x's don't change. So add 2, add 2, add 2. So when you graph this, this would be 0 up 3. This would be right 1 up 2. And this is right 2 up 3. So we started with an easy one. And basically what's happening is your parent looks like this. And we moved him right 1. And we moved him up 3, up 2 to get our final graph. So rather than me having you show all these movements, we're just taking the parent and writing the final points for the graph. All right, so let's get into things that are a little bit more complicated here. And before we do, I want to talk about something real quick. I'm having you draw this little picture for a reason. It's actually going to be more beneficial to you than what you think. For example, square root looks like this. The parent points are 0, 0, right 1, up 1. If you reflect over the x-axis, you can look at your little picture and go, oh, my final graph better look like that. If you have square root and you reflect over the y-axis, their final graph should look like that. So this little picture is helping you out. So this sideways snake is a cube root. If we reflect it over the y-axis, isn't our new graph going to look like that? So this little picture, use the picture to help you out. So when you have things like reflections over the x-axis or the y-axis, use your little picture to know what your final graph looks like. All right. So let's do a problem. This is 118. G of x is equal to the cube root of negative x plus 2. Now, the cube root, its points are the same as the cubic. Left one, down one, 0, 0, right one, up one. But the cube root, I'll give you a hint, goes left and right like that. I'll give you the points also. So for the cube root, if you put in a negative 1, you get a negative 1 out because you can take the cube root of a negative. The cube root of 0 is 0, and the cube root of 1 is 1. So these are just like the cubic. That's all I'm going to do for you. It's 11:25. You have to be back here at 11:30. You only have 5 minutes. All right, so let's see how it goes. You're going to be back here at 11:30. All right, I'll see you back, 11:30. All right, hopefully you made it back. The transformation here in the correct order would be left 2. So remember that this is minus a negative 2. Don't mess it up. You're going to get the whole thing wrong. If you mess it up, you can't mess this up. Inside is a reflection over the y. Don't mess it up. You'll get the wrong graph. So reflect y. So that right there tells me that this graph is going to look like this, not that. So when I finish, I made this little change right here so I know what my graph looks like. So this would be negative 2 to the x, negative 2 to the x, negative 2 to the x, and the y doesn't change. We did math aerobics. Reflection over the y is a horizontal movement. A horizontal means x. So we negate the x, negate the x, negate the x. The y stays the same. So when you graph, this would be right 3, down 1, right 2, 0, and right 1, up 1. Now, when we started the year, a lot of you would have drawn a line. Now that's going to give me a heart attack because that's not a line. This cube root is never going to be a line. So the reason why I had you do this over here is so you could graph it. So your graph should look like this as a reflection over the y. Therefore, it should go like this. Right? Right. So remember, I'm teaching you a quick way to graph. So there's a few things you have to remember. You have to remember what the cube root looks like. You need to know that reflection over the y is a mirror image, so it's going to look like this, so that when you come up with 3 points, you can graph it. So we're doing this instead of putting 20 points in a table. So you guys better get this, because if you don't get it soon, I'm just gonna make you make tables. And so instead of having the work that you have, see if I can find it real quick in my book, you're gonna have to make a bunch of tables, which is gonna suck up your entire life. So I can't find it right now, but I've showed you before, you know, all these tables. And I really don't think you want to do that. But if you can't get this, then I'm going to have you make tables. And that's going to suck up a lot of your time, because it's going to be very tedious. So I need you to take time out. Here you go. So you want to do this? So this is what you're going to end up doing. If you can't figure this out, you don't do what I say, and you don't study, you're going to have to make tables. Because I don't know what else to tell you. You know, I'm showing you a quick way to graph, and either you get it or we'll make tables. That's it, period. Now remember, when you have vertical or horizontal stretches and compressions, you have to multiply. So I'm going to make up my own problem. So once again, you should recognize right away what this is. You need to know, is this inside or outside? Is this a horizontal or vertical stretch or compression? I'm going to state it and see if we can do it. All right, it's 11:35. You're going to be back here at 11:40. So 5 minutes. All right. So, like I said, they didn't give you any problems like that, but you should know how to do this. So this is inside, so it is a horizontal stretch by 3, because you have to take the reciprocal. So, like I said, you have to remember it. I can't remember it for you. Horizontal stretch by 3, and then down 1. So this is a quadratic, and the quadratic points are left 1, up 1, 0, 0, right 1, up 1. Horizontal stretch means multiply the x by 3, multiply the x by 3, multiply the x by 3. The y's stay the same. Down 1 means subtract 1 from the y. So subtract 1 from the y, subtract 1 from the y, subtract 1 from the y, and graph. So left 3, 0. Zero down 1. Right 3, 0. So the question is, does that look like it was horizontally stretched? Yeah, it looks pretty fat. Was stretched. But you guys got to remember these. I mean, if you mess up on this first step, you mess up on the entire problem. So horizontal stretch, whenever you have a B, you take the reciprocal. So let me make up another one. That's a negative. So first of all, do you know what square root looks like? So square root goes off to the right. So you're going to state the transformation in the correct order. Write the transformational points and graph. Okay, it's 11:43, so you're going to be back at 11:50. All right, if you can't remember the points for this, what you're going to do is you're going to substitute numbers into square root of x and come up with the points. All right, I'll see you in the teams. Okay, I discovered something that I need to tell you, and this is it. You cannot have a negative under a radical, a square root. So this is imaginary, and so you cannot have that. But you can have a negative under a cube root. This is -1. So a square root of -1 is an imaginary number, which we can't graph imaginary numbers in the Cartesian coordinate plane. The cube root of -1 is -1. So I need to clear that up in period 1. So I made a note to myself. But with you guys, for the parent points, you can't put in a -1 under square root. So the square root of 0 would be 0, and the square root of 1 would be 1. And that's why square root only goes to the right. There is no going to the left. Unless it's h, this is going to be left 3, so it's h is going to move it. But the parent doesn't go to the left. So the transformation here is left 3, and this is reflect y because it's inside, and that's a horizontal reflection. So I'm going to change this picture right now. So reflection over the y means it's going to look like this, not like that. And like I said, I like to work with my little picture so I know what to expect at the end. So reflect over the y is like a mirror image over the y-axis. All right, so left 3 means -3 to the x, -3 to the x. Reflect y is this movement. And that's a horizontal movement, which means negate the x, negate the x. And by the way, in this particular problem, if you do not follow this order, you will get the wrong graph. So right 3, 0, and right 2, up 1, and that's scary. Like, what do you do with those 2 points? Well, you drew a picture over here to tell you. So we decided that reflection over the y was going to look like this. So just make it go like that. So think about this. Your parent looked like this. You move the parent left 3. And then you reflected that over the y-axis. So isn't that right? Doesn't this show the parent shifted left 3 and reflected over the y-axis? Yes, it shows it. So let's do some more of these. So yeah, there's a lot to remember, but I can't remember it for you. You're going to have to study and remember these things. You can't just hope that it mystically is going to come to you. You know, that's not going to happen. It's not going to mystically come to you. You're going to have to put forth an effort to remember these things. And if you don't, you're not going to remember them. It's just real simple. And that's what makes this class different than sixth grade math. This is what makes this class different than eighth grade math, ninth grade math, algebra 1, geometry, is that there's a lot to remember. And the only person who's going to remember it is you, and you're going to have to make an extra effort to study and remember it. If you don't, then it's just simple. You won't remember it. It's real simple. Okay, let's do another problem. Okay, ready? H of x equals a negative 1/2 times the cube root of x. Now you can have a -1 here. In fact, there's 3 points for this, and they're the same as the cubic. So you have to know what this looks like. Does it look like the up and down snake, or does it look like the left and right snake? All right, it's 11:55. I'm going to see you back here at 12. Actually, I'll give you an extra minute, 12:01. So I'll see you back here at 12:01. All right. So in this problem, the cube root does not go up and down. It goes sideways, left and right. And the transformation this is vertical, so this is a vertical compression. Do not flip the vertical. You're only flipping the horizontal. Okay, so vertical compression by 1/2 and reflect x. Okay, the points for the cube root are the same as the cubic. Left 1, down 1, 0, 0, right 1, up 1. If you can't remember it, then you plug in values. So you can have a -1 under a cube root. So the cube root of a -1 is -1. The cube root of 0 is 0. And the cube root of 1 is 1. So back up here, vertical compression means multiply the y by 1/2. So when you multiply the y by 1/2, you get -1/2. Multiply the y by 1/2, 0. Multiply the y by 1/2 is 1/2. So now reflection over the x is a vertical movement. So that means negate the y. So the x stays the same. When you negate the y, that would be a positive 1/2, positive 0 is 0. And this would be a -1/2. So when you negate things, if it's negative, it becomes positive, positive becomes negative. Now you graph it. So left 1, down 1/2, 0, 0, right 1, down 1/2. So that's something's not right. So I can tell because the points should be in a line. So where did I mess up? So multiply by 1/2, multiply by 1/2, multiply by 1/2. When you reflect x, you negate the y, negate the y, negate the y. So this isn't right. I gotta erase it. Can you guys see where the error is? Sometimes it's easy to start over. So it is a vertical compression by 1/2 and you reflect over the x. So your points for this, for the parent, would be left 1, down 1, 0, 0, right 1, up 1. So multiply the y by 1/2. Multiply the y by 1/2. Multiply the y by 1/2. So reflect over the x means negate the y. So this would be negate the y, negate the y, negate the y. So this would be left 1, up 1/2. 0, 0, right 1, down 1/2. So there we go. Now, reflection over the x means that if you reflect this, it would look like that. So that's a mirror image. So that's what it should look like. So this would go up like this. This would go down like that. So like I said, I like to mess with this little picture to make sure that I know what I'm doing. See that? So I had this picture, reflect over the x means it looks like this, like a mirror. So I think I made the mistake up here somewhere. This is correct though now. All right, so if you've never done an assignment in here, I hope you do this assignment. These transformations are going to be coming back again and again and again. So I'm hoping that you will know what the parents look like. Make sure you know the order and make sure you know what A, B, H, and K do to the graph. Now remember that with vertical compressions and stretches, you do not take the reciprocal. You only take the reciprocal when it's a horizontal stretch or compression. Otherwise, what you see is what you get. This is a vertical compression by 1/2, reflect over the x-axis. All right, so that's it for today. Have a good rest of the day, and I hope you do the assignment. All right, have a good day.